14.44. The balance wheel of a watch vibrates at an angular amplitude theta, angular frequency W, omega, and a phase angle phi equals 0. A. Find expressions of angular velocity d theta over dt and angular acceleration d squared theta all over dt squared as a function of time. B. Find the balance wheel's angular velocity, angular acceleration when the angular displacement is theta, and when its angular displacement is theta divided by 2 and theta is decreasing. So we can say that theta of t for part A, theta of t is equal to theta of t is equal to theta cosine of wt. Okay? So then d theta all over dt is going to equal our angular velocity of time equals w theta sine of wt. Then d squared theta all over dt squared equals our angular acceleration of time, which equals w squared theta cosine negative w squared theta cosine of wt. So then, for part B, for theta equals theta cosine of wt, cosine of wt, so 1 equals cosine of wt, and wt equals 0. Then we can say that since that's equal to 1 we can say is sine squared of wt plus cosine squared of wt equals 1 minus cosine squared of wt. So then sine squared of wt equals 0. So wt equals 0 and a of t equals negative w squared theta. Okay? So then at theta halves, you're going to get 1/2 equals cosine of wt. So wt equals pi thirds. And then sine squared wt equals 1 minus cosine squared of wt. So then sine squared wt equals 3/4. And so then w of t equals negative w theta times the square root of 3/4. And then a of t equals negative 1/2 w squared theta. And those two are, as theta decreases, cosine of wt is decreasing.